Good afternoon. I'm here to present our position paper titled A Knowledge Ecosystem for the Food, Energy and Water System, and this is joint work with my PhD students, Anas Khatib and Daniel Baron. We are from the University of Missouri, Kansas City. So here's the motivation for this work. As you know, there are diverse sets of data that are available today on the food, energy, and water systems. And these data sets are published by government agencies like USDA, USGS, and so on. However, they are in various formats that cannot be easily integrated. And also, there's a lack of rich ontologies that would enable you to actually model the domain knowledge. And as a result, what we can see is that these data sets are difficult to consume by intelligent software systems. And that makes knowledge discovery and decision making harder. So our goal is to come up with a system that would lead to modeling of knowledge and enable reasoning over the data in the food, energy, and water ecosystem. Okay? So our position is to come up with a knowledge ecosystem for the FEW system, and there are three things that we would like to consider. One is to enable semantic data integration of these heterogeneous data sets. Second, we would like to develop an evolving knowledge base with rich ontologies. And finally, we would like to be able to reason over this knowledge base in order to discover actionable insights and also validate scientific hypotheses. Now, our premise is based on the use of semantic web technologies, which have been around since the late 90s. However, more recently, semantic web technologies have been widely adopted in applications on the web, as well as in domain-specific areas such as biopharmaceuticals and defense. For example, Pfizer made use of semantic web technologies to manage their pharmaceutical data. E-commerce companies such as e-commerce sites such as that of Best Buy were able to use semantic web technologies to improve the quality of search results for their users. Media companies such as BBC and the New York Times have published data using semantic web standards. Linked data is a real-world collection of knowledge bases with over 50 billion facts that is available to many domain experts to leverage the data and build new applications and innovative applications for different use cases. Bio2RDF is another example of the success of semantic web technology on the web. It's a knowledge base of life science data. DataGov is another example where publicly available data sets and that of the government have been published in RDF as well, although not all the data sets are available in RDF, which is the data standard for the semantic web technologies. I would like to point out FIBO is a standard that will enable the financial industry to model and harmonize their diverse data sources so that systemic risk analysis could be done in a better way. And this all started as a result of the credit crisis that happened in 2008. Now, you may wonder, how is data really modeled using semantic web technology? And the standard for modeling the data is called as the Research Description Framework, or RDF. In RDF, each statement or RDF statement is modeled as a triple, which has a subject, a predicate, and an object. And each statement essentially is an assertion or a fact. For example, here you have the subject, which is denoting an entity Alice, whose name is shown by the literal Alice. Now, if you have a collection of such statements, you essentially have a very large directed label graph. So your data representation is in the form of a directed label graph. Now, you can go beyond triples, and that's called as an RDF quadruple, where in addition to the subject, predicate, and object, you can have a context. This context, also called as a graph name, can be used to capture the origin of the data. Okay? So triples that have the same context are said to belong to the same RDF graph. Now, here's an example. We have 4 quads here, And the first two belong to the same RDF name graph, whereas the next two are from two different RDF graphs. Now, to show you an example of how really do you query such data, there is a query language called Sparkle, which is the recommendation by the W3C for RDF data. And in Sparkle, a query looks as shown here. Just like SQL is for relational database systems, Sparkle is for RDF. And in this example, we are essentially interested in finding matches for graph patterns. We want to find all persons who knows Bob, and also we would like to know the actual name of those people. And as a result of this query execution, we essentially have a result in a tabular form which contain the bindings for the variables in the queries, and the variables are basically the ones that are prefixed by question mark. So if somebody is really interested in thinking of how to tackle the storage issue, how to tackle the query processing issue of diverse data sources, so Semantic Web Technologies provides you an avenue to explore. Okay? So when your data sets are diverse, when data is heterogeneous, and you want data to be easily integrated in a schema-free fashion, then one way to, or one technology to consider is the Semantic Web Technology. In addition to just modeling the data, you can also model the knowledge. There is a knowledge representation language called OWL, and that can enable you to model individuals, classes, properties of classes, and relationship between classes and individuals. Okay? For example, here is a picture where I show a class of all persons, and under that you have class of man, class of woman, and you can describe relationships such as John is married to Mary, man is a subclass of person, and so on. So essentially you have a way to model different concepts in a specific domain, and of course this requires the expertise of a domain scientist to help in building these ontologies. Okay? A large part, of course, would require human intervention, but in this position paper, we are trying to propose a way to automate the discovery of certain ontological properties. Okay? Now, once you can define the ontologies, you will be able to make use of the reasoning capability of Semantic Web Technology to, given a set of axioms and assertions, you would be able to draw some conclusions, and that could be used to do hypothesis validation. Okay? So here is a proposed idea where we are essentially saying, let's build a knowledge base using Semantic Web Technologies on diverse data sets coming from the food, energy, and water systems. And let's use the power of reasoning in Semantic Web Technologies to draw conclusions, to validate hypotheses, and gain actionable insights from the data. So as you can see, the entities and concepts that we would like to model are quite diverse, quite rich. And here is an example of a sample crop data which we can basically map into our representation called RDF by identifying the subject, predicate, and object along with the context. So essentially your data now would look like this graph that is shown here. For example, corn is a source of ethanol and so on. And of course, I'm not a domain scientist. I made up this example. There may be flaws in it, but it's up to you to discover those. But essentially, we are looking at graph data, modeling your diverse FEW data sets. And in order to infer properties in OWL, we don't want to do everything manually because that would be too time consuming. We are suggesting the use of Markov logic networks, which have been very popular in entity recognition, in classification, information extraction. And through the use of Markov logic networks, we would be able to discover relationships such as same as, is different, or different from, and so on. So that's our kind of thought process. And hopefully, through OWL2 reasoning, let's have an example here where a rancher claims that they have received less than an inch of rainfall in the last few months. A researcher looks at the wedge DRI value for the rancher's county and observes that it is green, indicating good moisture levels. Now, these two statements look contradictory at first, but then if you were to use the power of reasoning, you could say, or you could verify that these two statements are consistent because the ranch had a type of grass which actually grew well in even with little moisture. Now, I think I'm almost out of time, but just to give you some insights on performance of Markov logic networks, we did a small test with about 12 million ground predicates, 19 formulas, and as you can see, the weight learning process takes several hours. The inference also takes several hours. And here I have some performance insights on query processing. We built a system to handle RDF quadruples and do query processing on RDF quadruples. And we were able to beat two popular tools that are out there on a variety of queries. So with this, I want to kind of make the community think of using semantic web technologies as a solution to integrate and manage the knowledge in the FEW system. If you have any questions, comments, criticisms, feel free to share. Thank you.